So we are going to discuss the complex mappings or transformations. Okay. So you know that a real function y equal to fx can be well understood by plotting the graph of y equal to fx. Okay. So the graph may be like this, or this may be not continuous, right? But we can discuss the properties of y equal to fx, or we can see the properties of y equal to fx by plotting the graphs, whether it is continuous, whether it is differentiable, etc. Okay, and for each x I have y, so there are only two variables, x and y, so therefore it can be plotted in a graph. Okay, now you consider a complex function w equal to fz. So here you see that z is a complex number and w is also a complex number. So you cannot actually clearly see in a graph, right, like this in a same plane. Okay, so this is your z plane, and z equal to x plus iy, so it is real axis, this is imaginary axis. So you cannot actually plot what is fz here. So therefore it is sometimes convenient to use another plane, w plane, and this is the real axis, this is the imaginary axis. So the points here are z and here the points are w. So corresponding to z, what happens for w? So that is transformation, okay, mapping. We can see in two planes, right? Some elementary transformations like translation, rotation and reflection can be easily understood or can be easily seen from by considering the corresponding points on z plane and w plane. Okay, for example, let us take the transformation fz equal to say z plus 1. So that is nothing but the corresponding image points are what? Z plus 1. So you see that z equal to x plus iy. So this is transformed to what? W equal to z plus 1, and that is nothing but x plus iy plus 1, and that is x plus 1. This is the real part of w and this is the imaginary part. So this is your u plus iv. Okay, so you see that u is actually x plus 1 and v equal to y. Okay, b doesn't change, but what our original x changes to x plus 1 in the w plane. Okay, so therefore this is usually a translation of one unit in the real axis. Okay, originally it was x, and now it is x plus 1. So therefore all points in the z plane will be translated by one unit in the real axis towards positive 1 plus 1. Okay, so for example, if 1 was here, then in the w plane what will be the corresponding point here? This will be actually 2, because 1 becomes 1 plus 1. Similarly, I was here, original I was here, but this I will be transformed to what? 1 plus I. Okay, so this, so therefore I becomes 1 plus I. So this is the translation. All right, so everything will be translated by one unit. Okay, so therefore, for example, suppose this is a triangle, in the z plane. So then that will be transformed to what? This will be transformed to this in the new plane. So that is the transformation of this triangle with vertices 0, 1, I to what? 1, 2 and 1 plus I. Okay, so this triangle will be transformed to this triangle, just shifted by one unit, you see. Okay, similarly you can consider the other part. For example, fz equal to say z plus z plus I. So what is this? This is a translation in the w plane to w plane, but this is towards upper half. Okay, one unit in the imaginary axis in the upper half. Similarly, fz equal to your z minus 1 will be again a translation, but translation is now towards left. because the translation is -1 unit. Okay, so that is the translation, one example of translation mapping complex. Now, so let us consider another example. So rotation. So for example, say let us consider W equal to say Iz. All right. So Z becomes what? W, and which is Iz. So therefore, in this case, you see that this is the Z axis, and this is Z plane, and this is the W plane. This is W plane, and this is Z plane. Okay. So here in this case, your W equal to Iz. So Z becomes what? Iz. So if Z equal to 1, then in the W plane Z becomes what? I into 1. So that is I. So I. So your original point was 1, but in the W plane it is what? Rotated. This has been rotated. New point has been what? Rotated by how many angles? Pi by 2 angles. So this is a rotation. So all other points will be like that. For example, suppose it is I. Okay. So this I will be rotated. I will be rotated what? Pi by 2. So it is -1. So in the image of I will be -1. Okay. 1 will be what? I. Alright. So that is simple rotation by pi by 2 angles. 2 angle. Alright. So this is an example of a rotation. Okay. So therefore this triangle, under this transformation, this triangle will be just rotated by your 90 degree. So 1 becomes I, then 0 becomes 0, so then I becomes -1. So it is rotated. Okay, so this is like that. All right. So next, let us consider the reflection. So suppose we consider the mapping W equal to Z bar. So in this case, you see that this is your W plane U, V, Y, 0, X. All right. So here your Z, suppose Z equal to here X plus IY is general point X plus IY. So under this transformation, your Z will be what? Just X minus IY. So U is X and this is minus Y. So therefore the point will be here. Okay. So X plus I will be here. The point will be here. Right. So for example, 1 plus I. 1 plus Y I under this transformation will be 1 minus I. It will be 1 minus I. Okay. 1 minus I. This will be 1 minus I. So it is just a reflection around the real axis. Reflection around real axis. This axis. Okay. So it is an example of a reflection mapping, reflection transformation. All right. So these are a few examples. So in the next video we will discuss more general transformations.